On a crisp afternoon in 2025, SpaceX's Starship embarked on its seventh test flight, a spectacle that captivated millions and underscored the audacious ambition of Elon Musk's spacefaring vision. This launch, marked by a successful booster catch, a dramatic upper stage failure, and revelations about the colossal Block 3 design, was a roller coaster of engineering triumphs and setbacks. Hosted by Felix Schlang of What About It, this event offered a thrilling glimpse into the relentless innovation driving SpaceX toward a multiplanetary future. Let's dive into the details of this historic flight, analyze its implications, and explore the jaw-dropping prospects of Starship's evolution, incorporating the latest trends in aerospace technology as of May 10, 2025. The launch, a nail-biter with streamlined precision. The anticipation for Starship's seventh flight was palpable, with SpaceX scheduling the launch for May 15, 2025 at 4 p.m. Central Time. The 60-minute launch window opened with fueling operations commencing at T-minus 45 minutes, a process that showcased SpaceX's relentless optimization. Remarkably, fueling time was reduced by 5 minutes compared to Flight 6, despite the Block 2 Starship's larger propellant tanks. This efficiency stems from recent upgrades to the fuel farm at Starbase, which now supports faster and more reliable cryogenic loading, a critical step toward rapid reusability, a cornerstone of SpaceX's cost reduction strategy. As the countdown neared zero, a brief pause at T-minus 40 seconds raised heart rates among viewers. Such holds are standard for SpaceX, allowing engineers to verify thousands of telemetry points. This flight, however, breezed through the checkpoint, a testament to the robustness of the Block 2 design and SpaceX's growing confidence in its systems. With all 33 Raptor engines roaring to life, the 5,000-ton behemoth lifted off, its ascent a breathtaking display of raw power. The launch, set against a backdrop of turbulent South Texas weather, drew comparisons to the Saturn V's Apollo 12 mission, which famously endured lightning strikes. Fortunately, Starship faced no such drama, and the ascent appeared routine, a remarkable feat for the world's largest rocket. Booster 14's catch, defying the odds. The booster's journey was the highlight of Flight 7, demonstrating SpaceX's pioneering approach to reusable rocketry. 2.5 minutes into the flight, Booster 14 executed a hot staging separation, with the Block 2 Ship 33 igniting its engines to continue toward orbit. Meanwhile, the booster prepared for its return, a maneuver that has become a hallmark of SpaceX's Starship program. However, a hiccup emerged. One of the 13 center engines failed to ignite during the boost backburn, leaving only 12 operational. This anomaly, visible from Ship 33's cameras, raised doubts about the feasibility of a catch attempt. Against expectations, SpaceX pressed forward. After the boost backburn, the hot staging ring was jettisoned, and the booster was cleared for a catch attempt, an audacious decision that underscored the redundancy built into the 33-engine design. As Booster 14 descended toward the launch tower, it successfully relit all 13 center engines for the landing burn, overcoming the earlier failure. The landing was a sci-fi spectacle. The booster slowed, reduced to 3 engines, and gracefully translated into the tower's mechanical arms, dubbed chopsticks. The arms clamped shut, securing Booster 14 in midair, a repeat of Flight 5's historic catch and proof that SpaceX can replicate this complex maneuver. Post-landing, the booster faced minor challenges. Venting to prevent overpressure sparked flames, but unlike previous flights, the booster remained intact, with all 4 Chinese undamaged. Lowered back to the pad, Booster 14 stood as a symbol of SpaceX's progress toward reusable boosters. With 24 more launches planned for 2025, SpaceX aims to refine this process, potentially reusing Booster 14 after diagnosing the engine relight issue. This catch was not the mission's primary goal, but a dazzling bonus, setting the stage for the Block 2 ship's orbital ambitions. Ship 33's demise, a propellant leak, and a rapid unscheduled disassembly. While Booster 14 stole the spotlight, Ship 33's journey was the mission's core objective. As the first Block 2 prototype, it featured thousands of upgrades, including larger propellant tanks, enhanced thermal protection, and improved Raptor engines. After separating from Booster 14, Ship 33's 6 Raptor engines burned smoothly, propelling it toward a suborbital trajectory. For the first 4 minutes, the flight seemed flawless, building on the success of 4 prior orbital attempts. Trouble emerged at 7 minutes and 38 seconds, when one of the 3 center Raptor engines shut down unexpectedly. These engines, capable of gimbaling to maintain control, allowed the ship to continue, but the situation deteriorated. At 8 minutes and 2 seconds, a second center engine failed, followed by a vacuum engine. With only 3 engines operational, all on one side, the ship likely entered an uncontrollable tumble. By 8.5 minutes, telemetry was lost, and footage later confirmed a rapid, unscheduled disassembly, RUD, during re-entry, as the ship fragmented spectacularly. Analysis revealed a propellant leak as the culprit, a gap between the tank dome and the fire shield, intended to protect the engines, allowed liquid methane to escape. This leak caused pressure to build beyond the structure's limits, rupturing the assembly like an overinflated balloon. Flames and propellant, illuminated by sunlight, were visible near a flapping hull piece above the payload bay, hinting at the leak's location. Elon Musk confirmed the cause, noting that the leak overwhelmed the venting capacity and possibly ignited, exacerbating the damage. SpaceX's response is twofold. Short-term fixes include enhanced leak checks, additional fire suppression, and increased venting capacity. Long-term, the Raptor 3 engine, currently in development, will eliminate the need for such fire shields, simplifying the design. This failure, while a setback, is par for the course in SpaceX's iterative approach. Flight 7's Block 2 ship was a prototype, and its demise provides critical data for refining future iterations. Implications for Starship's future. The failure of Ship 33 necessitates a mishap investigation by the Federal Aviation Administration, FAA, which could delay Flight 8. If the ship's re-entry deviated from its designated flight path, the investigation may extend beyond June 2025. Musk, however, remains optimistic, suggesting the launch window will hold. Flight 8 is likely to repeat Flight 7's profile, focusing on orbital insertion and re-entry, with potential tests of regeneratively cooled thermal protection tiles, a technology critical for lunar and Martian missions. The booster catch, meanwhile, reinforces SpaceX's reusability goals. With 2 successful catches, SpaceX is poised to scale up operations, potentially reusing boosters by late 2025. The engine relight issue, likely a flight computer safeguard, highlights the complexity of Raptor ignition, a process requiring millisecond precision to avoid explosions. SpaceX's ability to recover from this anomaly during the landing burn showcases the robustness of its systems. This flight encapsulates SpaceX's philosophy. Bold risks yield breakthroughs, but setbacks are inevitable. The booster catch advances reusability, while the ship's failure refines Block 2's design. As SpaceX targets 25 flights in 2025, each launch will build toward a fully reusable Starship, capable of delivering 150 tons to low Earth orbit, LEO, and enabling missions to the Moon, Mars, and beyond. Block 3, a colossal leap forward. While Block 2 grapples with teething issues, SpaceX is already eyeing Block 3, a design that promises to redefine rocketry. In a recent statement, Musk revealed plans to increase Starship's height by 10 meters, from 125 to 135 meters, before potentially expanding its diameter beyond the current 9 meters. This marks a significant shift, as the diameter has remained fixed since 2017, when Starship, then the Interplanetary Transport System, or ITS, was downsized from 12 meters to 9 meters. A larger diameter, potentially 12 meters, as in the original ITS, would transform Starship's capabilities. Rocket geometry explains why. Increasing a cylinder's radius yields greater volume with less surface area compared to height increases, reducing material weight while boosting propellant and payload capacity. A 12-meter Starship could accommodate up to 42 Raptor 3 engines, producing 11,760 tons of thrust, triple that of the Saturn V. Such a configuration could lift 300 tons to LEO in reusable mode, rivaling the unbuilt Sea Dragon, a 1960s concept for a 550-ton payload rocket. The implications are staggering. A Block 3 Starship could deploy mega-constellations, construct lunar bases, or ferry hundreds of passengers to Mars. Its thrust and payload capacity would dwarf all existing rockets, including China's Long March 9 and NASA's Space Launch System, SLS. However, scaling the diameter requires a complete overhaul of manufacturing and launch infrastructure. Ring segments, transport stands, and the launch mount must be redesigned, essentially creating a new rocket. SpaceX's Starbase facility, already a hub of innovation, would need significant upgrades to support this behemoth. The Raptor 3 engine is central to Block 3's ambitions. Unveiled in 2024, Raptor 3 offers higher thrust, 280 tons, 230 tons for Raptor 2, improved specific impulse, and a simplified design that eliminates components like the fire shield implicated in Flight 7's failure. These engines, combined with a wider booster, would maximize efficiency, enabling unprecedented mission profiles. For example, a fully reusable Block 3 could support NASA's Artemis program, deliver massive space telescopes, or establish permanent Martian outposts. Trends shaping Starship's evolution. Starship's development aligns with broader aerospace trends in 2025. Reusability, pioneered by SpaceX's Falcon 9, is now a global priority, with companies like Rocket Lab and Blue Origin pursuing reusable systems. Starship's booster catch and rapid turnaround goals push this paradigm further, aiming for airline-like operations. The successful catches in Flights 5 and 7 position SpaceX as the leader in this race, with competitors years behind. Additive manufacturing, or 3D printing, is another trend enhancing Starship's production. SpaceX uses advanced 3D printed components for Raptor engines, reducing costs and accelerating iteration. This technology, combined with Starbase's high-throughput assembly line, enables SpaceX to produce Starships at an unprecedented rate, supporting the 25-flight target for 2025. Artificial intelligence, AI, also plays a growing role. SpaceX's flight computers leverage AI to optimize engine performance, detect anomalies, and execute complex maneuvers like the booster catch. The engine relight issue in Flight 7, likely mitigated by AI-driven diagnostics, underscores this capability. As AI advances, future Starships may feature autonomous navigation and real-time failure mitigation, critical for deep space missions. Sustainability is another focus. Starship's methane-oxygen propellant, produced via in-situ resource utilization, ISRU, on Mars, aligns with eco-conscious trends. SpaceX is exploring carbon-neutral methane production on Earth, using renewable energy to power Starbase's fuel farm. These efforts position Starship as a model for sustainable space exploration, contrasting with expendable rockets like SLS. Challenges and opportunities. Despite its promise, Block 3 faces hurdles. Scaling the diameter requires significant capital, potentially straining SpaceX's finances amid Starlink expansion and Tesla's robotics ventures. Regulatory oversight, as seen with the FAA's Flight 7 investigation, could delay timelines, especially if environmental concerns arise over Starbase's expansion. Geopolitical tensions, including competition with China's space program, add pressure to deliver on schedule. Yet, opportunities abound. NASA's Artemis program, targeting a 2026 lunar landing, relies on Starship's Human Landing System, HLS variant. Successful Block 2 flights in 2025 could secure additional contracts, bolstering funding. Starlink's profitability, projected to exceed $10 billion in 2025, provides a financial cushion for Starship's development. Partnerships with private entities, such as space tourism ventures or asteroid mining startups, could further offset costs. Public engagement, fueled by What About It's coverage and SpaceX's live streams, sustains momentum. The channel's 2 million monthly viewers, coupled with immersive experiences like redline helicopter tours over Starbase, foster a global community of space enthusiasts. These tours, offering $25 off via redlinehealy.com/Felix, provide unique perspectives on Starship's construction, reinforcing public support for SpaceX's mission. A vision. Beyond Earth Starship's 7th flight, with its blend of triumph and tribulation, encapsulates the high-stakes journey of space exploration. The booster cat showcases SpaceX's mastery of reusability, while Ship 33's failure highlights the challenges of pioneering new designs. Block 3's proposed scale, potentially a 12-meter, 150-meter tall Titan, promises to shatter records, enabling missions once confined to science fiction. As SpaceX refines Block 2 and lays the groundwork for Block 3, the company is redefining humanity's place in the cosmos. Trends like reusability, additive manufacturing, AI, and sustainability amplify Starship's potential, while challenges like funding and regulation test SpaceX's resolve. Yet, with each launch, Starship inches closer to making life multiplanetary, a vision that, as Felix Schlung reminds us, never gets old. For those inspired by this journey, supporting What About It via subscriptions, likes, or purchases at shop.whataboutit.space directly funds the photographers capturing Starship's saga. To delve deeper into the Raptor 3 engine's evolution, check out the channel's recent deep dive. As SpaceX prepares for Flight 8 and beyond, one thing is certain: the future of Starship is as boundless as the stars it aims to reach.